So, today I will start discussion on this course experimental physics 1. So, this is the lecture 1. So, basically I will give introduction about this course. So, this concept we will cover in this lecture is basically the aim of the course, the syllabus of the course and the laboratory and the apparatus. So, about this we will discuss in this lecture. So, as you know, the aim of this course basically we want to learn about the experiment on physics. So, there are many topics on physics and we will discuss on selective experiments. So, we have designed the course in 3 modules. So, experimental physics 1, there we will discuss experiments on mechanics, general properties of matter, thermal properties of matter, sound, electricity and magnetism. Then experimental physics 2, there we will discuss experiments on optics and modern physics, and experimental physics 3, in that module we will discuss experiments on solid state physics and modern optics. So, each module is of 30 hours course, and at present we will discuss only module 1, module 2 and module 3 may be discussed in successive semester. So, this course is not only for undergraduate students of physics, rather it is compulsory for all undergraduate students of science, engineering and technology who have to deal with instruments in any point of time during their career and profession. So, this course will make you understand the working principle of common devices through their applications in different experiments with particular aims. Means in this course we will discuss different experiments, their different tools, different parts of apparatus will be used, and through application in those experiments we will learn about the devices which will be frequently used in your career and in your profession. So, as for example, that all of you have seen the utility of the X-ray, MRI, CT scan, ultrasonography, ECG, etc. in hospitals and clinics. Also, if you look in any branch of science, whether in teaching laboratory, research laboratory, industry, hospital, agricultural field, everywhere instruments are used for specific application. To understand the basic principle of the instruments, to handle the instruments efficiently and even to think, to design an instrument or experimental setup for specific application, this experimental physics course will act as a foundation of the students apart from the degree in BSc, MSc, BE, ME, BTech and MTech. Also this course will have positive feedback for the national level examinations like GATE, NET, JAM and JEST conducted by IIT, UGC CSIR, IIT and ACRB respectively. So, syllabus of this course means experimental physics 1. So, I will discuss about the basic analysis in the laboratory. So, when you will go to laboratory, you will perform experiment, specific experiment on different topics in physics. So, but there are common rules and regulation, there are some common things that everyone has to know. So, that is basically how to take data, how to analyze the data, what is the source of error in the measurement, how we can minimize the error in the measurement, how to calibrate the instrument, how to plot the data in graph, okay. And then after calculation you will get result, how to interpret that result and what are the precautions in the laboratory. So, these are the common phenomena. So, that I will discuss, and then we will discuss some basic tools in the laboratory. So, that is all the time you need, it is for most of the experiments you need these common tools. So, those are this meter scale, slide calipers, screw gauge, magnifying glass, nut, bolt, screw and their driver, galvanometer, ammeter, voltmeter, multimeter, cathode ray oscilloscope, that is a CRO, resistor, capacitor, inductor and so on. So, these are the common tools, common components of any laboratory in science. So, I will discuss about those basic tools, and then we will go the specific experiments. So, we have selected some experiments, almost around 30 experiment we have selected for this experimental physics 1. So, experiments on mechanics, general properties of matter, thermal properties of matter and sound. So, these are the experiments we have selected that we will demonstrate in this course. So, determination of the restoring force per unit extension of a spiral spring. So, this is the one experiment on mechanics. Okay. So, you know the spring. Okay. So, spring has restoring force, if you extend it or compress it, okay, it want to go back to its original position, equilibrium position. Okay. So, how to measure the restoring force per unit extension? Okay. So, that experiment we will perform, we will demonstrate. Then second experiment, determination of the acceleration due to gravity using compound pendulum. Okay. So, G, gravitation acceleration due to gravity. Okay. So, this is the universal constant. So, how to determine this universal constant using the compound pendulum. So, that experiment we will demonstrate. Then third experiment, study the normal modes of oscillations of a compound pendulum and measure the frequencies. Okay. So, this oscillation of a compound pendulum, okay. So, it has basically different modes. So, one mode is called normal modes. Okay. So, what is the frequency of these normal modes? So, that experiment we will perform and we will measure the frequency of the normal modes of the oscillation of the compound pendulum. Okay. Then fourth experiment is study of the free oscillation as well as force oscillation using pole pendulum. So, this is another type of pendulum. So, using that pendulum, pole pendulum, so we will measure the free oscillation and force oscillation of the pendulum. So, it is basically in oscillation, you know, this there are natural frequency of oscillation, then if you apply force on this oscillation, so externally, so then it is force oscillation, or another oscillation we tell damped oscillation, means there are some resistance when it is oscillating, there are some resistance, it may be due to air, okay, air resistance, okay, some maybe some other resistance also, this due to eddy current, etc. So, due to this it is called damping. Okay. So, that is called damped oscillation. Okay. So, here we will demonstrate this free oscillation and force oscillation using the poles pendulum. Then fifth experiment will go for the study of transverse wave and longitudinal wave. You know the string, if you take a string, okay, and just you disturb it, then it oscillates. So, that is the transverse oscillation. So, that will study this transverse oscillation, and this longitudinal waves, basically this the compressed of, say, when some waves are moving to the air. So, air, this basically is air particles compressed and elongated. Okay. So, it is basically displaced along the direction the waves are propagating. So, that is basically longitudinal waves. So, we will demonstrate, we will study the transverse waves as well as longitudinal waves. So, the sixth experiment will demonstrate that is the determination of the moment of inertia of a flywheel. So, how to determine the moment of inertia of a body. So, here we will take this body as a flywheel and demonstrate how to measure the moment of inertia. So, this way there are some other experiments. Seventh experiment, determination of Young modulus of elasticity of a solid. So, general properties of matter in this category. So, if we will how to measure the Young modulus of elasticity of a solid, how to measure the surface tension of a liquid, how to measure the viscosity of a liquid, how to measure the thermal conductivity of a material. Okay. So, these are the thermal properties of the matter. Then linear expansion coefficient of a material. Okay. So, these experiments will demonstrate. Then next 12th experiment, this verification of Dulong-Petit's law. Okay. So, this specific heat related experiment. So, for this we will discuss, and then determination of the Stefan-Boltzmann constant of black body radiation. So, these are the basically experiments on the heat. So, then next another experiment on heat, this experimental determination of Joule's constant, okay, J. So, that how to find out this Joule's constant, that experiment also will perform, and then some measurement on electricity. So, for this 15th experiment, this variation of thermo EMF as a function of temperature and determine the unknown temperature. Okay. So, these are basically it is a thermometer of this thermocouple, using the thermocouple how to measure the temperature. Okay. So, we will discuss physics behind this thermometer, and then we will demonstrate how to measure the temperature, unknown temperature, using this thermometer. So, first we have to calibrate this thermal this thermocouple. Basically, due to the difference of the temperature, it generate EMF. So, that is the thermal EMF, thermo EMF. So, temperature versus this thermo EMF, that one has to calibrate. So, after calibration then you can find out the any unknown temperature. So, that experiment we will discuss. Then another experiment on as a thermometer, this platinum resistance as a function of temperature and determine the unknown temperature. So, this is another thermometer, platinum resistance thermometer. So, that also we will discuss. Then experiment on sound, this how to determine the velocity of sound in a air medium. So, this measuring the velocity of light, measuring the velocity of sound. So, these are the basic parameters. So, how to measure these basic parameters. So, in that group, so one experiment we will discuss, that how to determine the velocity of sound in air medium. So, then experiment on electricity and magnetism. So, there this determination of figure of merit of a deadbeat galvanometer. So, when you are going to experiment on this electricity, so this galvanometer, voltmeter, ammeter, right. So, these are the basic tools. Okay. So, one should know about these basic tools, basic apparatus. Okay. So, this is one experiment, so which will make you familiar with this galvanometer, voltmeter, ammeter. Okay. So, what is figure of merit and what it tells about the galvanometer. So, we will discuss about the deadbeat galvanometer and how to measure the merit, figure of merit of this galvanometer, that experiment will perform. Then this what is the current sensitivity and charge sensitivity of a ballistic galvanometer. Okay. So, different kinds of galvanometers are there. Okay. So, for deadbeat and ballistic galvanometer are very useful for the lab. So, we will do experiment to know about the deadbeat galvanometer and ballistic galvanometer. Then other experiment on electricity and magnetism are this measurement of high resistance using the capacitive discharge method. Okay. How to measure the resistance? Okay. Resistance having different range. So, if it is in say kilo ohm, mega ohm. Okay. So, then we tell it is a high resistance, and then if it is milli ohm, micro ohm. So, we tell it is a very low resistance, and then in between there is some other resistance. So, here we will demonstrate how to measure the high resistance, how to get the value of high resistance. So, there are different methods, but here we will use the capacitive discharge method. Okay. And then another experiment, next this low resistance. So, how to measure the low resistance? So, we will use, again it has different method, people use different methods. So, here we will use the method that is called Kelvin double bridge method. Okay. So, next experiment, how to measure the capacitance of a capacitor. So, you know this resistor, capacitor, inductor, these are the basic electric or electronic components, right. So, we should know about these basic components. So, basically to know about those components, so we will do some experiment, so that you can be familiar with these basic components. So, we will measure the capacitance of a capacitor and check the formulas for the capacitor and capacitance of capacitors when they are connected in series, when they are connected in parallels, and then we will study the charging and discharging of a capacitor and determine the time constant of the capacitor. next experiment we will do this the variation of the reactance of the LR circuit. So, reactance is equivalent to resistance basically. So, resistance of the LR circuit, LC circuit, okay. It is a reactance, impedance, resistance. So, these are equivalent term only depending on the combination of the circuit, whether it is only R, whether it is LR, whether it is LC R. Okay. So, depending on that this different name impedance or reactance or resistance. So, we will study the variation of reactance of the LR circuit with the frequency of the AC source and determine the self inductance of an inductor. Okay. So, then next experiment we will see the study the resonance of LCR circuit and determine the Q factor of the circuit. So, LCR circuit. So, quality of the circuit is determined measuring the Q factor of the circuit. So, that experiment also we will do, and then next experiment this, as I told, this resistor, capacitor, inductor, these are the basic components. So, this next component is inductor. So, we will study the variation of mutual inductance with the angle variation between the two plane circular coils. So, coils basically is the inductor. Now, if you take two coils, so interaction with this between these two coils, so that is called mutual inductance. So, how mutual inductance varies when the angle between these two coils will vary. So, that experiment will perform. So, basically this will give you or teach you about the inductor, and then you know this, if current flows in a conductor, so it generates magnetic field. Okay. So, that type of experiment will perform. So, we will determine the magnetic field of a straight conductor as a function of current and the distance from the conductor. So, how magnetic field depends on the magnitude of the current, how magnetic field, magnitude of the magnetic field depends on the distance of the point where we want to measure the magnetic field. So, the distance of the point from the wire. Okay. So, as a function of this current and distance, we will measure the magnetic field when current flows in a straight conductor. Then we will study the variation of magnetic field with distance along the axis of a circular coil, okay, when current will pass through the circular coil. So, circular coil, if we pass current through the circular coil, so how magnetic field varies. So, we will measure the magnetic field along the axis of the coil as a function of the distance of the coil as a distance of the point where we want to measure the magnetic field from the center of the coil. Okay. So, that experiment we will perform. So, this basically will teach you how to generate magnetic field. Okay. So, in our laboratory for different experiment you will see that we will use the magnetic field. Say you want to measure the magnetic want to measure the variation of resistance of a material as a function of magnetic field. If we apply magnetic field, whether resistance of the material changes, if changes, how it changes. Okay. So, when you want to study this type of problem, you want to demonstrate this type of experiment. Okay. So, you need magnetic field in the lab. So, how to get the magnetic field in the lab? So, this is the way generally we use the electromagnet. In electromagnet is nothing but the two Helmholtz coil, okay, we use to produce uniform field between the between these two coils. Okay. So, in that uniform field we place our material, and then we vary the magnetic field, varying the current in the coil, and then we measure the resistance of this material at different magnetic field. Okay. So, here this is the basic experiment, you know, this it will. So, you will learn how to generate magnetic field in the laboratory. So, basically this is the purpose to choose this experiments. And then next experiment is a measurement of the induced voltage in a coil as a function of magnitude and frequency of the current in another coil producing magnetic field. Okay. So, you know this Lenz's law, this Faraday's law, Faraday's induction law, right. So, basically if you have a coil, okay, so if you pass current through this coil, so it will generate magnetic field. Okay. Now, if you take another coils, okay, so now if you take this coil without flowing current in this coil, if you take this coil close to this coil which is producing magnetic field. So, this magnetic field is nothing but the lines of force, right, magnetic lines of force. So, these lines of force will pass through this second coil, okay, and so that we tell this flux, this magnetic lines are passing through this, and the second coil we tell this flux passing through the second coil, okay, and magnetic field is nothing but the flux per unit area. Okay. So, now this coil, now this second coil is in flux, is in magnetic field. Now, if there is a variation of the magnetic field or variation of the flux link with the second coil, if it varies with time, then there is a induced EMF generated in this second coil. Okay. So, this induced EMF, it is basically proportional to the change of the rate of the flux. So, if phi is the flux, so d phi by dt, that is the rate of change of the flux. Okay. So, this induced EMF is basically equal to minus d phi by dt. So, why minus? It is minus basically is this due to this EMF, induced EMF, there will be induced current in the coil, okay, second coil. So, now due to this induced current in the coil, so when current in the coil, so it produces magnetic field. So, that magnetic field direction will be such that it will oppose this original magnetic field. Okay. So, that is why this minus sign is given. So, it will oppose the magnetic field of the first coil. Okay. So, in second coil, this direction of the EMF should be such that means direction of the current should be such that, so the second coil will produce magnetic field, induced magnetic field, that field will oppose the original magnetic field. Okay. So, that is why it is the induced EMF is equal to minus d phi by dt. So, this is another very nice basic experiment that we will discuss, and then we will discuss the determination of the Fourier spectrum. You know, Fourier analysis of signals. Okay. So, any signal, it is, if it is of one frequency, that is fine. Now, most of the signals is not of one frequency, is the superposition of the many frequencies. Okay. So, Fourier analysis is used to separate those frequencies. Okay. So, that is the analysis of the spectrum. Okay. So, this is called so if we take any spectrum, it has different components of the frequency. Now, there is the how to find out the different component of this of the frequency in that spectrum. So, that is basically is a Fourier spectrum. That spectrum. So, we will determine that basically frequencies of the Fourier spectrum in form of square wave, triangular wave, or thus half sinusoidal waveform using the CRO. So, again another basic instrument in the laboratory, that is the CRO, cathode ray tube, cathode ray oscilloscope. Okay. So, this is the basic instrument. So, using this experiment will help us to learn about the CRO. Okay. So, we will do experiment, and for each experiment, most of the experiments say there are some common tools that will be used. So, that is the application of these common tools, okay, in different experiments. So, first I will discuss some basic tools, and what are the basic tools? That is what I told. It's a screw gauge, and then slide caliper, then meter scale, then voltmeter, then galvanometer, then CRO, cathode ray oscilloscope. These are the basic instruments. So, in most of the experiments, okay, experimental setup, so these tools are used, okay, these apparatus are used. So, so before I go to discuss this particular experiment wherever I showed you, so I will discuss about the basic instruments. Okay. So, so how should be? So, these are the experiment we will discuss with time. So, then you have to go to laboratory, you need laboratory, and then you need apparatus. Okay. So, how should be the laboratory? This is the I think you see these students when go to the laboratory. So, somebody has somebody maintain the laboratory. Okay. So, student do not bother about the laboratory. So, they get the ready made setup on a table, and they perform the experiment. Okay. So, this is I think we have to look in different way. So, you have to think if I want to develop a laboratory, so how laboratory should be. So, that if you think, so then this so I believe that this laboratory should be a well lighted room with humidity and temperature control. The room should contain cases or cupboards or a large closet in which the apparatus can be stored when not in use, because you have to save your setup, and when you are fabricating, generating, producing something. So, you have to take care of saving them also. Okay. So, this there should be some arrangement for keeping the apparatus when they are not in use. Then there should be table with power socket for each experimental setup with sufficient space surrounding the table, and then there should be more common tools such as screwdriver set, a soldering iron, a multimeter, a magnifying glass, meter scale, slide caliper, screw gauge, galvanometer, voltmeter, ammeter, etc. Okay, these are very common tool, and it should be always available to the students. So, it should be close to the hand of the students. Okay. And then there should be a small store with basic components such as this family of nut, bolt, screws, family of wires, resistors, inductors, capacitors, breadboards, lenses and mirrors, etc. It should be always these are the basic components, and various kind of these components should be in the laboratory, okay, because these are small components for anytime you may need them and it should be available to you. So, there should not be wastage of time that it is not there. So, because if you need one screw and if screw is not there, you cannot do the experiment, or what you want to do that you cannot do immediately. So, I think these are the basic components which should be available in the laboratory. Okay. So, I think these are the introduction about this course, and then next we will discuss basic components and some common tools in next class. So, thank you for your kind attention.